Welcome back. This is going to be part 3 of the Rowe R85 Jukebox repair set of videos. Back in part 2 of the series, I took some circuits out of the actual jukebox, brought them here to the lab to actually take a good look at. And those circuits are this control board and this main control board right here. And if you'll go back to that episode, you'll know we took this apart. I mentioned disconnected all the wires here, took this out, took it all apart, and I said I would replace all the electrolytic capacitors inside because there's a good chance they're no good. On the smaller board here, there was in fact a very large capacitor which had a hole inside of it, and that's usually not a good thing. I also removed a lot of corrosion that was on some of the boards, particularly the main control circuit here. And I said at the end of the video, once everything was cleaned up, that I would put it all back together and I would take it over to the owner's house. Now, of course, I went ahead and did that. And what happened was, keep in mind this thing had not worked at all. When we turned it on, after we reconnected the boards, the machine started making a horrific noise. And that was kind of a good thing and kind of a bad thing. And I say it like that because it didn't do anything at all before. So to have anything, any kind of noise, any kind of movement in this machine shows that there's some kind of signs of life. What I did was I brought the tablet back with me again, and you can actually see this is a diagram that was inside of the machine. And they mentioned that's the bill acceptor control box. Now, we weren't exactly sure what this circuitry did. It just said it was like a control module. But indeed, it does hook up to the bill transport mechanism up top here. And we wondered, John and I, the owner, if we can actually operate this machine without the actual coin and dollar acceptors. And the noise that the machine was making was actually the bill transport mechanism. And that makes sense because the large capacitor specifically that had the hole in it was in the control box for that bill acceptor. So that seems that fixing that got juice up to the transport machine, because you can hear the actual solenoid kicking in, you can hear the motor kicking in, and it was just making this whining noise. So of course we shut everything off and started tracing everything out and figured, yep, that's definitely what it is. And John actually, he's pretty mechanically inclined, so he's actually going to take that unit apart and mess with it himself and see what exactly was wrong with that. But knowing that, and that's it, by the way, removed, you can see, you know, it's got some belts and it's got some all kinds of stuff. There's a little solenoid over here, but knowing that that machine is starting to work means that this project definitely isn't hopeless. So what I did was, you can see these two wires over here. This is actually where they connect up to that control module. There's a mid connector here, and then there's actually another set of wires, another connector, if you will, that connects up to that main board. And I started poking around. You can see off to the side over here, there's a on-off service button. So I flipped that down into service and started messing around with some stuff in here. And it seems like this machine is going to work. What I did was I was able to put manual credits on this, and hopefully I have a picture indicating that. Basically, on the main control board, this guy up here, there's different buttons that you can push. You can put this into its own test mode. You can see up here it says record number 11, time selected 5. You can actually go through and see how many times each record was played and the whole 9 yards. I cleared out that memory. There's a little Memoric reset button here. It's like a little recessed reset button. You actually have to stick something in here to do that, which of course I did. And just fiddling around with this, it kind of got the machine working a little bit. We were able to actually select a record, and it said it was making the selection, but the turntable mechanism didn't actually start going, which was kind of like a setback, if you will, because we thought, well, you know, this thing's going to start working after all, and it didn't. But going back to that diagram, here's your actual turntable mechanism. The turntable's at the bottom, and this is where it stores all the records around here in this carousel. His particular device doesn't have these little wall box power supplies like it mentions. That spot's vacant. Same thing with the disco control. That's for, I believe, the lights around the outside edge of the jukebox, which his doesn't have either. This little box over here is the power connector where all the mains comes in and separates off to all the other devices, and I'm sure the power transformer stuff's in there if that's needed. And then this wooden box over here is where the actual amplifier board is. This little board over here is where all the selectors are as far as like what each denomination is, you know, if it accepts dollars or quarters or whatever, and you would set different jumpers in here to do that. And that all links into the main control board. So knowing that the control board works, and yes, we were actually able to disconnect the bill acceptor and take that completely out of the mix, we know that the machine does work up to a certain point. So what I figured, let me delve into this, and I spent, you know, a good maybe hour, 2 hours over his house looking into this. There's that actual main power section. You can see all the different taps that go all over the place. Another top view. I took this so I could see the little LEDs lit up. All those indicated correct voltage, 8 volt DC, odd voltage by the way. And you know, everything seemed right with this that I can test. But I noticed there was a front panel that flipped down, and that allowed me to get further into the machine. And I noticed there was actually another control board right underneath the turntable, and that's the guy right here. And I took that out figuring, well, you know, everything else had caps in it. Maybe this has got some bad electrolytic capacitors in there too. It wouldn't hurt to check it out. So out that came. Obviously it's here on my bench. Here we go back to that same dollar acceptor circuit. You can see these connectors over here is where I disconnected the actual transport mechanism on top from. And this is actually completely disconnected now, and it still allows you to make selections. But I took this because it's still showing the fault code. Now, perhaps if John rebuilds the acceptor machine, this particular device will work again, but that's more if you want to keep this into a working commercial unit, or if you just want to make it into you know, a nostalgic thing where you could pump dollars or quarters into it. But he just really wants to keep the thing in the living room and be able to just allow it to play. So keeping it in test mode perhaps and making manual selections on it would probably be the best way to do that. But at any rate, you know, I took this up close picture to show everything lit up, and it occurred to me as I was looking at that, there are some other boards in the top, namely this one up here, which would show you what the selections are, and then this one, which obviously you'd make the selections are. And looking at it, yeah, it's pretty crusty. So I figured, you know what, I went through the treatment, I cleaned all the other boards up, might as well do this. You can see the date code, this one's 1980, which is even older than the other stuff. And I said, yep, and there they are inside. This is, by the way, the lid flipped up. You can see that evident in this picture here. The top of the circuit, the main control board's over here, and all the wiring goes up. Here's your speakers. This is the back side of the menu board, so this is flipped upwards. And I said, there's just a couple connectors on here. Let's just disconnect those. I'll take them home. I'll clean them all up. And you get the idea. Now, this is that selector box. I said that this is where you actually tell the device how much each selection cost you. And that little diagram I took the picture up, that's over here. The amplifier board's underneath it. You undo the screw, this thing flips up, and then you can easily get to that. And there's the actual section of the amplifier where the taps are to connect the various speakers to. And you can see there's this big beefy transformer in here. This is actually a pretty wild sound amplifier board. There's a better shot of it looking into there. And I just flipped that up just to see if there was anything, you know, interesting inside there. Don't know if that amplifier board works because we can't get the turntable to start turning records. If that starts to go and the sound doesn't sound so good, that'll be the next thing to diagnose. But once again, going back to that picture of that dollar acceptor, that's just pulled off to the side. And I took some pictures of some other things in here, like some of the ballasts, because some of these tubes don't work. There's a tube and there's also a starter. I have, actually my dad has a bunch of these starters lying around from his old electrician days. So I'll probably dig some of those out. I may even have some of these ballasts lying around. That's ancillary though. I want to make sure this thing works first before we actually do any kind of restoration stuff on the lighting or anything in there. But here you go. This is a good shot. You can see everything as a whole. And this is what that little door removed. You could probably see right over here, and on the other side behind this piece of wood are the catches that connects to, and the whole door just flipped down this way, and then the main thing flipped up that way. In fact, this piece of wood is holding the main door up because the shocks are actually shot. And one of those other ancillary things, if we get this working, there's a good chance we'll probably replace those shocks just to have them, you know, just to make that easier without having to have like a broom handle or something holding it up. And this is the top side. I had to take this picture upside down. It was easy ways. You can see the buttons over here, and you can actually see this is the little screen with the selections, you know, whether you have a selection being played, if you have any remaining, or whatnot. And you can see in the mode I have it in, the switches I flipped and whatnot, got it to be able to make selection here. And I did make a selection, but if you look, some of the numbers are cut off. This was actually supposed to be 1, 2, 0. And you can't see the top row. So either there's a bad connector on this board or something's wrong up here. Now there are no electrolytics on this, as you can see. This board, however, does have one at least that I remember. If not, there's two, but we'll look into that in a minute. And that's actually all the pictures I have for the project at his house. But the idea is since we don't exactly know why this isn't working, we got to trace out the logical steps. Obviously, it's getting power. Is it the right power? That I'm not sure about. I didn't actually put a voltmeter in there and see what's actually coming out of it. But it does seem that's working because there was an 8-volt little LED indicator light on the main brain that was lit, indicating that it was getting, in fact, 8 volts DC. So we know that's working. These boards do light up. Like I said, the LEDs do light up. But knowing that some of the characters don't light, especially a top row, that's got to be some kind of a connector issue, something going on with this. So it definitely doesn't hurt to check these out. Now, if you remember the other video, I said that these little plastic cases in this backing here, this just slides right off, as you can see. And the construction here is really no different than the other ones. So once you pop that off, you'll see you have the same setup with the foam pad and of course the paper backing. Now it's kind of curious, you can see there's a couple points up here that are kind of worn in, and that's because these sections up here are starting to come through the actual foam, and this foam has the same problem as the other ones. It's not as deteriorated, but it is pretty bad. You can see I am able to peel it off, but it's not going to come off in one steady piece. So the treatment for what we're going to do here is we're going to tear these all apart. This one obviously is already in its bare board form, but this one will have to come out. All the buttons will get popped off, and I'll just put this up in frame real quick just so we can see where they all line up. Clearly the popular button has been popular because the text is pretty well worn off of it. These are all you know, pretty nice switches, because with stuff like this that gets repeated use, especially back in the day, they had pretty good switches on them. But we'll take all this stuff out. Yep, indeed there is just one electrolytic cap here. I didn't mention, but maybe I did, but this board is actually what controls the turntable mechanism. And all these different LEDs, as you can see, like turntable motor, tran motor, I'm not sure what tran stands for, mag motor, that's probably the magazine motor, detent toggle, all these different things over here lit up when the thing was attempting to move. And at one point, from it just sitting there, the magazine just spun on its own. It a little bit. It didn't go completely around, but it moved. There was a record on the turntable, and the needle actually moved off of it, and it picked up the record and put it into position. But it did it pretty slowly, like it was hesitant. So, not 100% sure where the problem outlies, and that's of course been par for course for this whole project. But certainly our efforts aren't going to be far off from trying to actually clean this board up a little bit. It seems that there's any issues like that, because after all, doing that to begin with did seem like it kind of got some kind of life into this machine. So I'd be curious to see, of course, what the next step will be. So I'll go ahead right now. I'll remove all this crusty kind of foam padding from here. We'll get the other pieces out of the way over here first so we don't make a mess of that. And we'll start the process of getting this cleaned up. Now, this is a 35 volt, 22 microfarad capacitor over here. And if my memory serves me correctly, that's a value I believe I picked up already. And I'll have to, of course, go through my parts bin over here and go search for that part and see if we have that. I think I have 50 volt versions of this, and if you remember what I mentioned in the other video, we can go up in voltage, we can't go down. So hopefully I do have that part. That'll be a thing. If I don't have it, I'll have to, of course, get one. But the other side of that is at the very least, we'll get all this foam cleaned off, because it is pretty nasty. And it'll be nice to see if there's any corrosion underneath this, causing any kind of issues. So without any delay, let me go ahead and take all that foam off and we'll get a little further look here. All right, that wasn't terribly bad. Of course, I used my friend the old toothbrush here, and it came off. This is all crumbly and it's kind of sticky, but definitely not as bad as the other one. That was pretty bad. The board doesn't look too bad right now. Now, there's a curious little issue going on here with one of the traces, and that's a little suspect. I'll have to go ahead, of course, and clean that up a little bit and see if there's actually indeed any kind of break in the trace there. But all in all, not horrible. Now, this was just brushed off. I didn't do any kind of treatment to this yet, so of course we will have to do that. And let me go through the parts bin now and see if I have this capacitor on hand. All right, while it does look like the other capacitors that I removed from the prior board, I actually did not have any 22 microfarad 35 volt caps. However, when I looked through my parts bin, I did find one. And yeah, they are the same value. I know one is a lot larger than the other, but these are a lot newer, and I'm assuming what happened here is just a changing in manufacturing. Obviously, something from the 80s versus something from 2000 whatever here is probably a lot, more efficiently made, so it doesn't need to be as big. But it is indeed the same exact value. It is a 22 microfarad 35 volt capacitor. So I'll go ahead and just get this guy out real quick and pop this one in its place, keeping in mind the electrolytic capacitors are polarity sensitive, and this one's marked with a little plus on the positive side. So of course I'll do the same thing. It doesn't need to be laid down like that because this thing's so tiny, but I'll take care of that one right now. And there's that capacitor put into place. Yeah, you can see how much more tinier it is than the other one. Now, curiously too, if you look at the back of this device here, and you look at the backs of these devices here, you notice this one's nice and shiny. Well, that's because I scraped off that black gunk that's on here. Now, that's some kind of surface oxidation. Now, that's, kind of a irrelevant thing, but it's very curious that kind of corrosions all over the backs of these devices here. Some of these are very large transistors, as you could tell by the base collector and emitter pins over here. But the other one has, up here you can see, there's a CAG setup. So I'll pull the codes on those and see what they are. But it's very interesting how that has that kind of corrosion on here. Also, it's worth noting, if you look around the section here where I soldered, the coating that they put on the top of this seems like it bubbled off with heat, which was very weird. It didn't do that on the other board. So I think it's a good idea to just clean this right now, because there's something going on with this. There's almost like a film on here. It's very sticky. Here's a little shot of what's going on. I sprayed this down with some isopropyl. You can see it's still wet. I'm just letting it flash off here. Yeah, that that seemed like that actually cleaned a lot of gunk off the board here. You can see it did the same thing the other one did. I just have this mess on my desk now. It's horrific, but yeah, these white circuit boards, they do get dirty pretty quickly. But you can see there's all this dark areas in the middle. Obviously where I can really scrub good, it came out much better, but it started eating away at that black stuff that was on the back of these things. So it may sound silly, but there's very good possibilities that a layer of film like that can just cause shorting out between these pins and stuff. It's very possible. I mean, if it's a conductive kind of film. By the way, this harkens back to the era when I used to actually repair cell phones. I used to work for Nextel. I was actually a Nextel, Sprint, Verizon kind of dealership. And we get a lot of people coming in with phones that were water damaged, and I came up with this way of actually attempting to repair water damaged phones. They, you know, my favorite one was somebody went and took their car to a car wash, one of those manual ones, and they got done washing their car, and somebody called them, and they actually dropped the phone in the storm drain. And it went back later on and retrieved it. They actually had something they passed down into the drain and pulled it up, and of course all the car wash soap and everything just made a real mess inside the board. But you know, spraying it down with icy and actually using a brush like this, I was managed to get all the corrosion off of it. And that one I actually soaked. I just took a container of this icy and sprayed it into another container and just soaked the whole board right in it for maybe an hour or so. Pulled it out, shook it off, cleaned all the stuff off of it, and the phone worked. I mean, it wouldn't even power up initially. So, you know, it's a hit and miss. I mean, honestly, I've had ones where you get a drop of rain on it and it just fried the phone. I've had ones and people drop it in their toilet and it worked. So really, it depends on where the corrosion hit, you know, all that kind of stuff. Obviously, subject for another time, but with these kind of things, you never know. Cleaning this stuff off like that, of course, is a good idea. You know, some people actually use deionized water. A lot of people use different things. The thing about using the icy, sometimes it does leave a little bit of a residue, as you can see, but that's not something to worry about because we have actual electronics cleaner here that will spray onto that, and hopefully that will help remediate that and get that cleaned up. But so far so good, not too bad. It's coming out better than it was originally. So I'm going to keep on the course just cleaning this board. After doing some cleaning on this board, it seems to me that some of these solder joints are actually bad. If you look in here, hopefully the camera can pick it up, but some of these pins don't look like they're actually making very good contact, and you can see there's actually a lot of cracks around it. So I'm going to actually reflow the solder around a lot of these pins over here. I'll check all those out. I did look at this trace, and it's kind of iffy. I'm not really sure what happened there, but you can see the scratches are actually on the board itself and not the trace. If I really want to, I can actually eliminate this trace and just use a wire and just wire it directly. That might be something I have to do, but yeah, as you can see, it's kind of weird. It almost looks like they're shorting out against each other, but you know, the multimeter is going to be the best way to do that. I'll just put one lead over here, and I'll put the lead over here, and I'll just check continuity between these just to make sure they aren't actually coming apart. But yeah, that one pin there, you can see it doesn't look like it's making very good contact. And bad solder joints, you know, are everything. That's you know, if you're not getting the right connection, then you're going to have intermittent issues, and that's definitely a way to diagnose this. So I'll go ahead and do that right now too. Or I had to put this project down for the night because it was just getting late, but I ended up finishing all the solder joints on the connectors. You can see here, 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 up here, and over here. There were definitely quite a few of those bad solder joints. I don't know if that's from inserting the large plugs into these things that may have disturbed it, or from this sitting under the turntable and just getting vibration from the thing from use over years. Not sure. Usually that's the case with those things. It is some kind of vibration or insertion that does that. So they're definitely a lot better than they were. Some of the worst offenders, I actually went in and completely removed all the solder with a solder sucker and then reflowed the joint with new solder. Some of the other ones I just reflowed it anyway. But those are all in really good shape. You can also see over here I removed the solder mask from both sides of the trace. Just cleaned that up a lot. And using a multimeter with a alligator clip on one of the probes, I just connected it to one of these pins down here, and then I traced out with the other probe these other pins just to make sure where there was continuity, where there should be, and where there shouldn't be, and everything checks out fine. So what I'll do over here is, since there's some exposed copper and up in here in this area too, I'll just hit that with some solder so the surrounding area just has that protective solder coating on it, and then I'll probably just hit it with a light coat of liquid electrical tape or something like that just to further protect it. But that's pretty much it for this particular board. It definitely looks a lot better than it did originally. And of course, once I'm done doing a little quick solder over here, I'll just give it a quick second clean with the electronics cleaner, and then I'm going to move on to the other board. And that'll do it for that. I know there's a lot of exposed connections on here, but I just feel more confident with those just being covered, simply because, you know, there is this protective coating everywhere here, and that's what's preventing that copper from corroding and turning all funky. And when you remove stuff like that, even though, you know, you might cover it with solder, there's always some spots that doesn't exactly get covered, because, you know, you are just scraping that stuff off. And you know, covering that with something like that just is going to prevent any kind of further corrosion or anything from getting into the surrounding area where the solder just didn't creep into. So let's move on to one of the other boards. I think we'll take a look at this big beefy switch set next. That's the best way I can describe it. All these do pop off. They just easily come straight off. So I'll lay these out in some sort of semblance of an order here, just maybe just even how they come off. I should mention all the screws for these are actually sitting in the original jukebox. There was a couple in the back here that I took off, just started disassembling all this while I was there, and I figured, you know, this is all just going to come out at the shop. Now it does actually seem that these are pushed in from the top up here, and possibly the board soldered in. Now that I got those off, it doesn't seem like there's any way that these things actually come off from the front. There are little retaining clips here, but perhaps, as I say that, perhaps it seems like they're actually pushed in from the front and soldered in from the back, and the retaining clip would be useful for taking this switch off after you desolder from the other side. Let me just poke around real quick and confirm if that is the case. Yeah, and I just desoldered one of these switches real quick just to see if that is the case. Yeah, that is indeed the case. But this is crusty. You know, that should be cleaned off. I'm not sure if that's part of the original process or if that's something that happened to this board afterwards, but yeah, that's pretty crusty. I'd like to get that off that board, clean it up as best as possible. Take a quick look at these little switches though. They're simple, just a couple contacts in the back. And I don't want to say it's a tactile switch. It is possible to open this, but you know, I don't really think it's necessary. But it does seem like, you know, it works. The best way to test this obviously is just, you know, put a multimeter on the thing and see if it has continuity, but I don't think there really is any reason to do that. But what I will do is just clean this up. Yeah, this is just filthy. But I'll do that and check to see if there's any problems with any of these pins over here. They look pretty good. I mean, there's nothing really going on here but a bunch of switches, but I will clean it up. Yeah, she's dirty. All right, now while this didn't come out perfect, it's definitely a lot better than it was. And that stuff was a pain in the butt to remove. It was really bad, and it looks like under certain angles it's still there, but when you look at it head on, you can see the board is definitely much cleaner than it was. And yeah, I resoldered in the switch that took out the bottom there. Getting this off required me to use an old gift card here, and just like use it to scrape some of the heavier stuff off. Again, with a trusty brush, and you can see this brush is getting pretty beat up from this cleaning procedure from this whole project here. It's actually getting this funky yellow color as all the old crap gets soaked into the bristles here, so I'll probably be chucking this pretty soon. But yeah, if you remember before, that table was just covered in all kinds of stuff That's from the isopropyl alcohol here. I'm just spraying that down, almost like saturating the board and just letting it run off. And you can just literally watch the clear fluid turn like yellow almost as it came off the edge here. And some of it was black, some was yellow. It was just real gunky, but the other side came pretty clean. There are some spots, and this is just where the metal itself is just pitted from age, but certainly a lot better. This cleaning stuff, this contact cleaner, this has actually worked pretty well. And yeah, it does say it works for sensitive equipment and stuff like that, and you can use this regularly just to keep the boards clean, but I'll probably have to pick up another can of that pretty soon because I'm going through it. But they even feel clean. Like before, you could just feel like this crustiness to it. It was kind of gross actually, but yeah, they're nice and clean now. So there's just the one board left. So this one, luckily, is pretty clean already. But if you remember, this was the one that had a problem with some of these lights not lighting up, especially the top row. So I'll have to see which way this board is supposed to be actually oriented in the case, which side's actually top and which side's actually bottom here. And I'm going to look at the pictures and see based upon the buttons. Now, just quickly looking at it, if I remember correctly, the 3 lights were at the bottom and then the other 2 were at the top up here. So I'll revert back to my pictures here in a moment, but the important things are going to be the connectors on here. You can see they have that wear from where it's been hooked in and out from the connector. So I'll check those guys out. What I'll probably do is slightly reverse engineer this and just see what the ground plane is, and then possibly which one of these I can make light up. And the way I'm going to do that is using my adjustable power supply over here, and I'll set it to a low voltage 3 volt, 1.5 volt, you know, something really low with a low current. And I'll probably just check each individual little segment on here just to make sure this works. But first things first, let's just give it a quick spray down anyway. All right, sprayed it down, cleaned it up, and I actually scraped down the contacts here so you can see they're a lot better looking than they were. If you remember, they had like dig marks in them from the contacts where the connector went in and out. So I just cleaned those up really quickly, made them nice and uniform. Still have a little bit more to do on actually. I have some really fine sandpaper. I'll just probably just give it just a quick once over with that. I actually just use the end of a screwdriver, just a flat blade here, just to clean them up, flatten them out a little bit more. I did find one bad solder joint. It wasn't bad like it was cracked, it was just bad like it wasn't completely filled in. And it was just like a dab of solder that was on there holding in the one side of this LED here, so I fixed it. Luckily, they do tell you which side the cathode is and which side the anode is. And of course, the cathode is the negative side, the anode is the plus side. And I always remember that, like anode, add, an, a, you know, plus, anode, cathode, negative. And we can kind of reverse engineer this whole thing and just see by flipping the board over what side is what. So if you look, C flips over to this top pin, the top pin comes over to here. That next component is these large resistors, which bridges over to this connection here. You can see those two side by side, and there are 2 separate pins for those. So if I put my actual power supply here, you can see I have it set up here in the corner. And this is set to 3 volts, and I have it set to a really low milliamp. 20 milliamps. See, yeah, there's the 20. And if I actually short these out, you can see it going between constant current mode. So right now it's actually drawing the 16, 17 milliamps. So I went ahead and connect these up real quick, and I'll just test out all the LEDs here just to make sure this is all working in the segments as well. And you can get an idea of what I mean. So there's that red LED lit up based upon those 2 pins there. So I'll go around and just do all that. And as you can see, one of the segments are lit. So the thing is now determining if this is the top or the bottom. So look at the pictures real quick. I have a feeling this is the top, and those were the ones that weren't lighting. And if I just move these across here real quick, you can see segment 1, segment 2, and segment 3. But the odd thing is I can't seem to get them to go through the other segments all around here. And I say that that's odd because there isn't actually any IC circuits on here. There's no chips on here to actually individually address, if you will, each one of these segments. And there's certainly not enough pins to do that. So a little bit more reverse engineering here. What a perplexing board. So these LEDs are the ones on the bottom. And then, of course, these run along the top here, so you can orient the board. This is the correct way it does locate. And checking out the segments, they did light up. And yeah, I can get some of these other ones to light in here, particularly the side ones. And it's all in the positioning of the alligator clips over here, depending on which one I clip to positive, which one I clip to negative, and so on and so forth. And yeah, just flipping those alligator clips around, using different ones for negatives and different for positives, I can actually make those all light. So there is some kind of multiplexing going on here, but it's not in this board. It's going to actually happen in the main control board, which is pretty interesting. Now, I suppose they did that just to keep all the electronics, the active stuff in one board, and just all the ancillary stuff in the other boards here, like all the passive components. So these are all going to be just resistors to limit the current to these individual drivers, but all the work is actually being done in the main board. So when you look at this to the naked eye, you're going to see a number drawn on it, but if you slowed it down, you'll actually see the numbers drawing in. And some of my videos, depending on which angle I have the camera set at and what mode I'm shooting in, sometimes the numbers over here in the distance do the same exact thing. In fact, that's the way all these LEDs work. They're just they're being drawn in at such a quick rate that your eyes are just saying that it's just one glowing character, but in reality it's not. It's individual segments being turned on and off really quickly. And that's why there's not contacts for every single segment. You'd have to have a big connector to do that. So yeah, it makes fundamental sense. It's just one of those things that when you're trying to trace everything out and wrap it around your head, it doesn't always make the most sense, but you know, after you actually, you know, use power leads like this, it does actually make a lot more sense. So I know they work. I've seen them light up myself, and judging by the fact that it was just connectors over here that I was able to manipulate to make them light up, indicates to me that there is a very good chance that it was something wrong with this card edge. If not, it's something wrong with the actual connector that plugs in here. And if it's not that, then I'll have to follow it down to the main board and of course recheck that. But that's pretty evident that that's what the situation was. So of course, where does that leave us now? Well, the final thing I'll have to do with everything I have in front of me right now is to actually go back to the cardboard that I used to make the backer for the large board, cut another piece of that backing out for this particular board, mount it back in this housing, and I'll take a ride over to John's house and put these in, and then hopefully we can get a little further into the puzzle of getting this thing to work. And with that, I want to thank you for watching this particular video and all my videos. If you're not already a subscriber, you can click up here and subscribe to my channel. I'll also have a couple videos down here in the corner of the screen you can check on. And with that, I want to thank you for watching. We'll see you next video.